Welcome to your video notes for Unit 3, Lesson 8. We have talked about slope-intercept form, and I just want to show you a little bit of the vocabulary that we're going to see today. Today, you're going to see words like linear equation. Slope-intercept form is a linear equation. We're going to talk about parallel lines, parallel, that's how you say that, and system of lines. Every once in a while, you'll hear me say system, and I will explain to you what that means. So those are 3 vocabulary words that you will hear in this video. This video comes to you in 4 parts in the form of examples. Part number 1, which graphs are parallel? We have 3 graphs in front of me. They all have an equation that go with the graph, and they have these points that I have conveniently labeled. What does it mean for lines to be parallel? Lines that are parallel, I guess I'll type this. Oh, okay, here we go. It's going. It's going to be green. Sorry if you can't see green. No, none of us can see green. Let me change this. Oh, what? Oh, they added more colors. Okay. Lines are parallel when they have the same slope. We know 2, even 3 ways to calculate slope. So we can do that with these graphs here. When I see a graph and I have to calculate slope, I do the rise over run business. All right, so here we go. This first graph, I'm going to start at this point. I have to rise 1, 2, 3. Let me make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm checking the scale because sometimes the tick marks aren't always 1 unit, and you have to count by the scale. So if they go by 2, you have to count by 2s. Anyway, that's just something I see in class. I have to rise 1, 2, 3, and then I have to run over. This is my rise over run, and I have to rise over 3, and I have to run over 2. So my slope for this first graph, graph A, by the way, you should sketch out these graphs. They don't have to be exact, but when you just sketch them out, you can plot the points on there too, and they can be estimations of the graph. Okay, graph B, I'm going to zoom in here, and I'm going to start here. I'm just picking any 2 points. I'm going to rise 1, 2, and I'm going to go over 3. Well, that's confusing. M is equal to rise over run, and my rise is 2, and my run is 3. So my slope is 2/3. And then for graph C, ooh, there's a 0, 0. I like using the 0, 0 point because it's really easy for me to tell what the rise and run is from 0 to any point on the line. So my rise over run is 3 over 2. So graph C and graph A both have slopes that are 3 over 2, and graph B does not have a slope of 3 over 2. So graph A and B are parallel. They have the same slope. Okay. What does it mean for lines to be parallel? Well, here's what else it means. Let me see if I can draw. This is going to be really hard for me because, like I said in earlier videos, it's really hard for me to draw straight lines on these tablets, but I'm trying. Okay. I basically took this graph, C, and I plotted it. 2, 3. You know, I got close. 2, 3. Yeah, I wasn't too far off. Maybe a little off. 1, 2, 3. Down here? Sure. Okay, so I also put graph C on here. And now graph A, this graph has 2 lines. When there are 2 lines, when there are two or more lines on a graph, that is called a system of graphs. Say you have a graph and you just have like lots of lines on it. All those lines are part of a linear system. They each have a name. Each line has a name. Each line has an equation, but they're all on one coordinate plane. So thus they're all in one system. Now, what does it mean for parallel lines? Parallel lines, man, I wonder if you guys could see this. What if I just zoomed in like this? Wouldn't that be better on your tiny chromes? Parallel. Now I'm having trouble clicking it. Click, come on. Parallel lines in the same system have zero solutions. Solutions to a system are where lines or intersect. Just as like a really, really quick side note. So parallel lines, whoa, those should be parallel. It's hard on this tablet because I can't see where I'm drawing. Okay. Parallel lines have zero solutions. All other systems of lines have one solution. That means they touch once. There's also a situation where they touch an infinite amount of times, but for this video, parallel lines have zero solutions. This should say solutions. It doesn't. It says just solution, but parallel lines in the same system have zero solutions. So go ahead and pause this video and you can summarize, how do you prove if two lines are parallel? What did we do in the video to prove that two lines are parallel? And then I'll meet you for part 2, example 2. Let a line L, and we're looking at this graph and L is right. L, this should be L. I'm going to name you L. L. All right, let the line L be given in the coordinate plane. What linear equation is the graph of L? So, when you see linear equation, you need to translate linear equation into either, in our case, for the next couple of days, it's y equals mx plus b. There are other ways to write linear equations. We have the standard form, which we've talked about a little bit, ay plus bx plus equals c. This is standard form. We are not going to write our equations in standard form tomorrow. We're just going to do this in our beautiful and our lovely slope-intercept form. Okay, so when it says write a linear equation, we're going to write y equals something, x plus something, and it's going to be for L. How do we do that? If we're going to use slope-intercept form, we need exactly two things. We need a slope and we need an intercept. So let's go find our slope and our intercept. Slope. Let's find our intercept first. Our intercept is really easy to find because you look at the y-axis and you just plot out where does it touch the y-axis. In this case, it's going to be 0, comma, -3. So this is our y-intercept. We're going to use that. -3 is our y-intercept. We're going to plug that in. And let's find the slope. Here's the thing about the slope. If you look at this graph, there's no big dots on here like I put in the first 3 graphs. So you have to make the dots yourself. So you have to look at this line. Maybe I'll highlight this so it's a little better for you guys. Oh boy, I get to draw lines again. I'm so good at this. Okay, so you have this line here, and you need to pick the points on the line. This solid line is made up of literally an infinite amount of points. So go pick a point that's easy to read. For example, 0, 3 is easy to read. This point here, what is this point? 3, -1 is easy to read. This point here, 6, 1 is easy to read. This point down here, -3, -5, that's easy to read. So you don't have to fill in all these points. You get to pick 2 of them. what is this one? 3, -1, and 6, comma 1. Okay, let's pick these 2 points here. We're going to find our slope. We're going to rise 1, 2, and we're going to run 1, 2, 3. So our slope is our rise over our run. I don't know why I'm using a red pen. Red pen is awful. Okay, 1, 2, rise 2 over 3. So our slope is 2/3. Great. Well, we have y equals mx plus b. Instead of m, I'm going to write 2/3. Instead of b, I'm going to write my y-intercept -3. Oh, I'm also going to get rid of that plus sign because if you add a negative number, you're really just subtracting. I was going to write b again. I apologize. Let me write 3. All right, so here is our beautiful linear equation. This is a linear equation. It looks great. I know this might freak you guys out, this fraction. Like, if you don't want to get used to it, you're going to have to. This is a linear equation. I think it looks great. Equation. The next part of this video is part 3. We are going to use, by the way, example 2 was how are we going to create a linear equation from a graph. Example 3 is how are we going to create a linear equation or a line or equation of a line with 2 points. All right. We're going to do the same thing. We need 2 things. We need a slope and we need an intercept. Slope, intercept. Oh, look. 0, 3, that's a y-intercept. I recognize that because the x value was 0, and if the x value is 0, the point lies on the y-axis. So my y-intercept is 0, 3. Actually, to be more specific, my y-intercept is equal to 3. My slope. Now I need to find the slope. And how can I find the slope if I don't have a graph? We have an equation. M is equal to y2 minus y1 over x2 minus x1. If this still freaks you out, please come in to see your teacher and your teacher will clear this up for you like that. But if this freaks you out, so please make a note like this and come clarify with your teacher. Okie dokie, let's do y2. This is going to be y1. This is going to be x2, y2. So I'm going to fill in my numbers. 3 minus 5 over 0 minus -4. So 3 minus 5 is -2. 0 minus -4 is +4. Use a calculator if this is freaking you out. I'm going to simplify -2/4, which is -1/2. Do you have to simplify? No. Do most people prefer it? Yes. Okay, this is m. All this is equal to m. Thus, I have something equals x plus something. My m is -1/2. I got that from here. And my y-intercept is 3. Ta-da! So now you can find a linear equation if you're just given 2 points. Very powerful stuff. 2 points, and you can create an equation that will predict all the points, an infinite amount of points. It's very powerful, people. Okay. Example 4. 4 boxes of pencils cost $5. We are going to write an equation that represents the total cost y for x boxes of pencils. What is the slope of the equation? What does that number represent? Then I have this box called reading strategy because I am going to do something here. I'm either going to annotate my box, or I'm going to rewrite my question in different words, or I'm going to highlight, circle, and underline, which is annotating, things I don't know, or I'm going to identify what I know and don't know. Something. I'm going to do a strategy. I'm going to show you underlining and circling keywords. I'm going to show you annotating. 4 boxes of pencils cost $5. Okay, so 4 boxes for $5. Okay. Write an equation that represents the total cost y for x boxes of pencils. So I need slope-intercept form. Write an equation. So what I did was I underlined it because that was a direction. And then I wrote y equals mx plus b to remind myself that is the equation I'm going to write. What is the slope of the equation? Slope is m. So it looks like I have to write an equation. I have to find the slope. And then I also have to find out what the number represents. And the reason why I'm writing 1, 2, and 3 is because I'm telling myself as I'm reading this, I have 3 things I have to do. So my reading strategy that I used annotating. See above. Okay. Oh, what number does this represent? Maybe I'm looking for a sentence. Okay, so that's how I annotated my problem. Now I'm going to do my problem. 4 boxes cost $5. So I have X is number of boxes. So for 4 boxes, I have the, oh geez, I can't handle that line. Okay, cost, I don't know what happened. Okay, $5. So that means if I have 8 boxes, it's going to be $10. If I have 12 boxes, it's $15. I don't know what this is going to help me, but I'm going to make a table. When I get stuck, one of my other strategies I do is make a table when I can. It usually helps in these problems. All right, I made a table. Now I have to, well, that's good because I have to make an equation and I have to find the slope. So my slope, I have coordinate points here. I have 4, 5, and I have 8, 10. I'm going to find the slope. 10 minus 5 over 8 minus 4. This is the y2 minus y1 business that we've done in class and previously in this video. 5 over 4. Okay, my slope is 5 over 4. That makes sense because for every 1 box of pencil, it's going to cost 5/4 of a dollar. Okay, what is my slope intercept? Well, when x is equal to 0, I guess I should fill this in here. When I sell when I buy 4 boxes, when I buy 0 boxes of pencils, it costs me $0. So my slope intercept, my y-intercept is also 0. So y equals mx plus b. My b is 0. My m is 5/4. And my x is my x and my y is my y. Okay, so my slope, I found the slope of the equation. I wrote an equation of the total cost and what does the slope represents. So this is where I write a sentence for part 3. The slope represents the amount of dollars it costs for 1 box. How about for every box of pencils? Every box of pencils. That means if I spend 1 box of pencil, when I buy 1 box, it costs 5 over $4, $1.25. If I buy 2 boxes, it'll be 2 times that amount. So the slope means that every time I buy a box, I multiply it by 5 over 4, which is the cost per box. So it's not every box, it's per box. Cost per box of pencils. It is a rate. In fact, it is a unit rate. Booyah, booyah. Okay. Go ahead and summarize the most important pieces of this video. You can even separate it by example 1, example 2, example 3, example 4. You can do it this way, where it's like, oh, these are my biggest takeaways from example 1, 2, 3, and 4. Thank you for watching this video.